Good day, everyone. And for now, we will be talking about chemical equations. So, chemical equations are symbolic representations of chemical reactions in which the reactants and the products are expressed in terms of their respective chemical formulae. Equations tell us about the reacting species and also resulting products of the in which the reaction takes place. So the coefficient of the reacting species and products tell us about the mole ratio of the elements or compounds in the reaction. An example of this chemical equation is the reaction between hydrogen gas and oxygen gas in order for it to form a product which is water. So in this chemical equation, 2 on the number 2 here and here on the product, these are called coefficient. Okay, and then hydrogen and oxygen elements here are called reactant. And water is the resulting product. All right. These are some of the difficult example of a chemical equation. So these are the products. The reactants, and then the product is this. Okay. On the first example, you need 4 hydrogen to react with PCl5 in order for you to have 1 mole of H3PO4 and 5 moles of HCl. Okay. On the second equation, SnO2 plus 2H2 or the hydrogen gas will result into water, 2 moles of water, and stannous or the tin. Okay, so that means you need 2 moles of hydrogen in order for you to react with stannous oxide to have water and also separate the stannous or the tin in this reaction as a product. So 2 is the coefficients. SnO2 and 2H2 are the reactants. All right. And water and Sn are the product. On the third equation, TiCl4 and H2O are the reactants. Number 2 here on water, the reactant is the coefficient. Number 4 also on the HCl. TiO2 plus 4HCl are the product, and it needs 2 moles of hydrogen to react with 1 mole of TiCl4 in order for you to have 1 mole TiO2 and 4 moles of HCl. It goes the same also with the other equations. So it needs 3 moles of KOH to react with H3PO4 in order for you to have a K3PO4 and 3 moles of water. These are the product and these are the reactants. Okay, these are the coefficients. Of course, here there should be number 1 here. So 1, 3, 1, 3 are the coefficients. The same also with the other previous examples. So On the last example, Na2S plus 2AgAl or AgI, that's iodine or iodide, with the resulting product is 2 moles of NaI and Ag2S. So these are the coefficient, okay, and the reactants and the product of the equation. Now let's talk about chemical reaction. Chemical reactions, on the other hand, are the transformation of chemical substances, either elements or compounds, into another chemical substance. So these two elements or compounds, if combined or there is an application of heat, there is a reaction that will take place. And what will happen is there is a breaking of chemical bonds between the compounds or the compounds, and then there is a rearrangement of the atoms to form a new product, that is chemical reaction. And of course, chemical reactions are represented by a balanced chemical equations, the one that we have discussed earlier, with chemical formulas symbolizing reactants and the products. Generally, they may either be reversible or irreversible. When you say reversible, that means the reaction can take place, but it can redivert again into what is the reactants. Revert again its reaction into the reactant level or the status. Irreversible is the reaction will not be able to revert again to its reactants. So it will form a product. Okay? Now, in chemical reactions, reactants are converted into products under, of course, particular circumstances. An example of this reaction is the magnesium and the reaction between magnesium and oxygen. If you're going to let it react, it will form a product which is the magnesium oxide. So this is what I've been talking about earlier. So there are many types of chemical reactions. So in these chemical reactions, it can be irreversible or irreverse, meaning it cannot go back again, or it cannot reverse the reaction. Sorry. So, for example, for a reversible reaction, it can do a forward reaction, forming a product, but it will do a reaction again, forming back to a reactant status, meaning the reaction is reversed. But in a irreversible reaction, from the reactants, it will have a forward reaction, forming a product, and it cannot do a reverse reaction anymore, going back into a reactant. Okay? So now for the reversible reactions that can occur in both forward and reverse direction. And the reactants can change to become products, and the products can also change back to the reactants. So can only occur in a closed system, such as in a solution. Then reverse reactions also are such reactions that never reach completion, and the ratio of the products to the reactants remains constant, and so such reactions reach an equilibrium. So when you say equilibrium, this is the consequence of the reaction happening simultaneously in opposite directions. It's It is a forward and reverse reaction. These are the example of a reversible reactions. Like for example, the nitrogen and oxygen. It can be uh, it can have a product of nitrous oxide, but this nitrous oxide can return back into a nitrogen and oxygen elements. Same also with hydrogen and iodine. It can form a hydrogen iodide, but this hydrogen iodide is not stable, and it will return back or reverse reaction into hydrogen and iodine again. Same also with hydrogen and nitrogen. So it will form an ammonia, but ammonia can return back nitrogen into nitrogen and hydrogen as the reactants. When you say irreversible reactions, these are reactions that only occur in one direction, or a forward reaction only. The reactants cannot change, can change to the products, but the products cannot change back to the reactants in a reactant form. So many reactions occur in this manner, as many reactants happen in an open system. So remember earlier, irreversible reactions usually opens in a or happens in a closed system. But in irreversible reactions, these can happen in an open system. So irreversible reactions, such reactions happens or achieve static equilibrium. When you say static equilibrium, it refers to the condition where the reaction occurring in a system is completely halted or stopped, and there exists a no movement between the reactants and the products corresponding to the chemical reaction. So now for the irreversible reactions, usually the reaction stops at a certain point when all the reactants are completely consumed and converted into a product. So it's either one of the reactants is used up already, so there are no more one member of the reactant to react. So an example of this reaction is the reaction between sodium and water to form sodium hydroxide and hydrogen gas. So sodium at a solid state and water at a liquid state, it needs 2 moles of water to react with the 2 moles of sodium in order for you to get a 2 moles of sodium hydroxide in aqueous solution. So that means in water solution. And then the reaction will have a release of the hydrogen gas. So another example is the reaction between magnesium and oxygen in order for you to form a magnesium oxide. So there you need a 2 moles of magnesium, solid magnesium, and then of course oxygen in a gaseous form. It will react 2 moles of magnesium and 1 mole of diatomic oxygen, then oxide, which is a solid. Okay, these are the types of chemical reactions. When you say combination or synthesis, that means you are combining the two reactants in order for you to get a new product, which is a compound. When you say decomposition analysis, that means from a compound, AB, it will form into two compounds or elements, which is A and B. So when you say replacement or single displacement, that means if you have a compound and then you have one element or compounds either way, the product here, so you can see the difference, A and C here will combine, and then what's left out was B in this. Okay, so for the double displacement, that means you are exchanging the either the cations or the anions. Like for example, AB the reactants CD, so the A will combine with D, and then the B will combine with C, with the letter with C element. So this will be your product AD and CB. So there are some special types of reaction. The combustion, which is, like for example, fuel and organic chemicals or solvents. Like for example, let's say, what you call this, something like ketones or alcohols. So for the redox reaction, there is an electron transfer from one atom to another. All right, so we're going to discuss about it later on. When you say neutralization reaction, this is between acid and bases. You have done this already before in your organic chemistry. So if you're going to react an acid and a base, the resulting product will be a salt and a water. So for example, HCl, that's your acid, and NaOH. So the product is NaCl plus H2O, correct? So here, this is also a double displacement reaction. So because if this is considered A, this is considered B, C, and D, the OH here, AD, this, and B and C will be here. All right. So B, C, or yeah, I'm sorry. I'll just going to erase it. Let me show you correctly. Sodium is C and B is chlorine. So here is A, H, and the OH is AD. Okay, for this reaction. So the example for the combination or synthesis is, like for example, if you have Fe or iron and sulfur, it will form a compound of ferrous sulfide. For the decomposition or single displacement, that is zinc copper chloride. So what will happen? Zinc will form to chlorine, resulting in a product of zinc chloride, and then copper will be left out as an element. All right. So for the double displacement, like for example, sodium chloride and the AgNO3. So of course, what we have learned earlier, Na will combine with this NO3, Cl will combine here with Ag. So that will be sodium nitrate and silver chloride. Lastly, the example for combustion C10H8. If you're going to add oxygen by heating or burning, you will have carbon dioxide and water. Lastly, for the neutralization or the acid-base reaction, the one that we have discussed earlier, HCl plus NaOH, it will result in sodium chloride and then water. So that's it for today. If you have some questions or reactions, you can send a message to me, or leave a message. Just comment directly. Good day.